This video presents experimental results for dynamic fabrics for motion generation. It accompanies the paper with the same name. The motivation behind the development of dynamic fabrics can be seen here in the video. First, you see static fabrics as they were initially presented, and you see that they have a hard time avoiding the moving, approaching obstacle. Our method, dynamic fabrics, is able to smoothly and in advance avoid that obstacle. You see that on the right. Dynamic fabrics can also be exploited for path following for mobile manipulation. We see here in the video that the mobile manipulator, composed of a mobile base and a robotic arm, is avoiding the obstacles while following a path, shown by the green sphere. In contrast to many other local motion planners, dynamic fabrics can follow a path in any arbitrary manifolds. Also note the low computational costs of that method. We also compared fabrics to an MPC quantitatively. We showed that a similar performance is reached while solver time can be drastically reduced. You see the motion of both methods here. As a highly reactive method, static fabrics are prone to local minima, as we can see on the left. Motion generation with static optimization fabrics is very slow in the proximity of obstacles, leading to high execution times in this scene. On the right, dynamic fabrics can make use of globally generated paths. The global path here is defined entirely in the end-effector space and not in the configuration space. Next, we want to further investigate the example from the very beginning of this video. On the left, you see static fabrics in action. You see an obstacle approaching the robot, and there is no motion of the robot until the obstacle is very close to the robot. This then results in a very sudden motion and avoiding behavior. On the right, you see the same scenario with dynamic fabrics. You can see that the robot is, in advance, avoiding the obstacle. This is only possible because dynamic fabrics with the dynamic pullback are able to incorporate the dynamics of the obstacle, such as their velocity and acceleration estimates. We show that dynamic fabrics can be applied to human-robot cooperation scenarios. In this experiment, the hand of the human is tracked by a motion capture system and fed into the dynamic fabric motion generator using a constant velocity model. We can clearly see that the robot is smoothly avoiding the human while converging back to the goalpost once the space is freed again. In the last example, we want to look at the mobile manipulator again. First, the robot follows a path without any obstacle. You can see the convergence to that path. Then, an obstacle is added to the environment. The obstacle is avoided naturally if it is in conflict with the path. Afterwards, the robot converges to the path again. Note how the robot exploits both the base degrees of freedom and the arm to achieve this goal.